Hello, in this video we're going to be talking about the laws of thermodynamics. Let's not waste any of your time. Let's get right to it. Now when we're talking laws of thermodynamics, one of the things that we want to emphasize is how it affects the energy, and not so much how, because the laws are just explanations of what is happening, but we want to look at what the energy looks like, what's going on with the energy in each of those laws. And one of the things that we'll spend some time talking about is entropy, and what's going on, what entropy means, what's it look like. We've kind of talked about this a little bit when we're talking about messy room, clean rooms, that kind of stuff. But we certainly want to stress what are examples, or what does it look like energy-wise in each of these laws. So our first law of thermodynamics, just like the first law of matter, just like the all those other first laws, is that energy cannot be created or destroyed. Okay, it just simply transforms into other types. And so when it comes to energy, it can transform from mechanical to heat, heat to radiant, radiant to heat. It just changes forms, much like our discussion of potential and kinetic energy. We showed that pendulum swinging. And in class, we'll look at simulations that showcase. You can see something moving like a pendulum, and you can see the graphs for potential and kinetic energy going back and forth from 100% to 0 to 100%, back and forth as the motion continues. And so that's one thing we want to remember. It's not created or destroyed. There's not any new energy. We don't lose any energy. It just transforms into a different type. Total amount stays the same, and so on and so on. Now, when we're thinking first law of thermodynamics, energy can't be created or destroyed. One thing we want to think about is that it just transforms. All right, when it comes to entropy and energy, think about a young, whether you think a child or even just a teenager, compared to an older person like myself, much older person. When you're younger, you've got lots of energy. Your metabolism is running high, and therefore you have higher entropy, and that's showcased by being more active. Much more active than a person, say like me, who's older, less energy levels, lower entropy, metabolism is lower from the cellular standpoint. The idea of those two variations that showcase the idea of entropy, that showcase the idea of the comparison between the two. Now when we're thinking entropy, okay, that when we think the second law of thermodynamics, entropy is just the idea of disorder or chaos. And naturally, in a spontaneous environment, it's always increasing. Okay, the entropy, the idea of something being ordered, like say a new something, maybe a new chair. Okay, but over time, okay, it begins to break down, begins to wear out. If a plant makes a new glucose molecule, it's very structured, very organized in the beginning, but over time, okay, it gets broken apart, and that's going to increase the entropy the idea of energy transformations proceed spontaneously, converting matter from a more ordered form to a less ordered form. Things can break apart naturally, as we've mentioned that a couple of times, but to put them together, that takes high levels of entropy, and that's why anabolic pathways, that's why endergonic reactions have to have that input of energy to get things going, because things can't get put together spontaneously, but they can break apart spontaneously, as we've mentioned plenty of times. So if you're looking at the diagram, in the beginning, when it's very ordered and structured, like that series of purple circles, but over time, that circle, that square will be broken apart, and that's going to create higher entropy, more disorder, more chaos from the movement. And that can happen naturally, but to put it together, to take away all the broken parts. So for example, say like you've got a concrete pad for a driveway, and over time the corners chip off and there's cracks and little pieces break off. That can happen naturally with just from the effects of the weather, the sunshine, the rain, freezing rain, or water freezing and thawing out, freezing and thawing out. All those things can break apart the driveway naturally, but to fix it, to put it all back together, that's going to take a lot of energy involved, and that's the concept of the idea of way to think about it. So if we think about entropy and the words that we've been using, entropy is associated with, or if you increase entropy, that should be associated with breaking apart molecules. So if we break apart a molecule, we're going to increase the entropy. If we build a molecule and store potential energy, the energy is not moving. So that's going to decrease entropy. So you can think entropy being connected with kinetic energy. If you're increasing kinetic energy, then you're increasing entropy. If you're decreasing kinetic energy, you are decreasing entropy. So any process that releases energy is going to increase entropy. So when we're talking cellular respiration, when we release those molecules, those sugars, break them apart, we're going to increase entropy, but we're also going to be building ATP. So in that concept, we're going to be decreasing entropy. So that's the idea of connecting entropy with our sets of words that we've been using. So that's our video on the laws of thermodynamics. The next time we get together, we're going to be talking about ATP. So we'll see you then.